So in this video, what we're going to try and do is we're going to want to be able to solve a linear system by adding or subtracting. So our objective at the end of this video, not perfectly, but by the end of this video, I want you to be able to solve a linear system by adding or subtracting equations. And what adding and subtracting equations are is basically solving them like we did before, but not the substitution method. We're going to be using a new method. So to solve by adding and subtracting, we have 4 different steps. Our book only gives us 3, but I added in a 4th step because I think that'll help make it a little easier than how the book has us do it. So, to solve by adding and subtracting, we're still looking for that solution. We're looking for that area where the 2 lines are intersecting. We're trying to figure out where it works for both equations. So the first step of adding and subtracting is just line up our variables. We need to line up our variables. That's going to be the first step when we're solving by adding and subtracting. And that may sound a little confusing, and I'll come back and explain to what that means. But first we need to line up variables. Our second step then will be to add or subtract. So again, in the substitution method, we substituted a bunch. In the graphing method, we graphed a bunch. The adding and subtracting method, not just a clever name, we're going to add or subtract both equations. Our third step then will be to solve for a variable. Be to solve for the variable. Once we've solved for the variable, it kind of is going to feel like the substitution method again because we need to end by substituting. We need to finish by substituting and then finding that next variable. So we're still going to be looking for the x and y coordinate, where they're crossing if we'd graph them, or if we substitute them in, we need to find the x and y. But now we're just doing a different method, and I think this method actually is a tish easier than the substitution method. So these are your 4 steps. I would pause the video, make sure you get these written down somewhere because these are the 4 steps we're going to follow when we're solving these next linear systems. So, solve by adding and subtracting. We have 2 linear systems. They're both in standard form. Our first step to solve by adding and subtracting was to line up the variables. And what that means is make sure we have an x over another x variable. Look at our y. We have a y. Is it over another y variable? Yes. No variable. Is it over another no variable? Yes. So that's all it's asking us to do when we line it up. And for us, we're lucky on this one, we lined up the variables already. It's already given to us lined up. Our second step then was to add or subtract. So what we want to do when we're adding and subtracting is we want to cancel out one of the variables. So what we're going to do is we're going to look at this like a big addition or subtraction equation. So, looking from, I'm going to go from right to left. If we added 11 and 13, would they cancel out? No. If we subtracted 11 and 13, would they cancel out? No. So we're going to ignore this part. Then we can look at the y's. If we added or subtracted 3y to 5y. So if we added 3y to 5y, would they cancel out? No. If we subtracted 3y from 5y, would they cancel out? No. So we're not going to worry about that one. If we added 2x and negative 2x, would they cancel out? Now think about that. What is 2 plus negative 2? 0. So that means they would cancel out. So what we're going to do is we're going to add these 2 equations. And this is where I think it gets much easier than the substitution method or the graphing method. What we do now is just add from top to bottom. So 2x plus negative 2x, 0. 3y plus 5y. Positive 8y equals 11 plus 13 is 24. We've now added our two equations, and that's what the second step's asking us for. So we're done with the second step. Our third step was then to solve. Can we solve for one of these variables? Well, there's only one variable left now because these two cancel out, our x's cancel out. We just need to solve for y. So to solve for y, I'm going to divide both sides by 8. This gets up. And we get y equals, what's 24 divided by 8? 3. So y equals 3. We've now solved for our variable. We got y. And just like before, we weren't fine with just one variable. We needed the other variable too. So we need to find what x equals. So to do that, 4 was to substitute into our equation. I'm going to take this 3. I'm just going to substitute it into the top equation. I get 2x plus 3 times y. 3y. My y is 3, so 3 times 3 equals 11. And now all I need to do is solve for x. So 2x plus 9 equals 11. Subtract 9. Those cancel out. We have 2x equals 2. Divide by 2. X equals 1. So now, our solution to this problem is x equals 1, y equals 3. So 1, 3. That's what our solution is to this equation. So instead of solving one of these for x or y, all we do is we add straight down, get one of them to cancel out, and then solve for it. It kind of cuts out a step in the substitution method for us to be able to find our y easier or our x easier. So this is just one example of how we do it.